Hey guys, so I've had to watch a lot of videos this week to review naming of ionic compounds and what they are and comparing ionic and molecular compounds. And then the last Tyler Do It video I asked you guys to watch was about naming molecular compounds. So I'm going to go over that real quick. And if you have any questions, please come to the Google Meet on Wednesday or just send me a message. But so with molecular compounds, it's going to be between two nonmetals. And the rules for naming molecular compounds are a little different than ionic compounds. And we're going to go through two examples. Okay, so the examples I have on the slide, and I'll write them out for you. Looks like this. So what this means, a little review, this means I have one fluorine atom and I have 5 oxygen atoms, and they've bound together to form a compound. So when I name this, okay, to note that it's a molecular compound, it's 2 nonmetals. So I can even go check on my periodic table. Here's fluorine, number 9, and oxygen is number 8. These are both nonmetals. And so I'm going to name them as I find them. Okay, so I will write fluorine. Okay, so I'm going to name the first element. And then I'm going to name the second element just like I would an ionic compound, and I change the ending to IDE, oxide. Okay, so fluorine oxide. But now these numbers here, in the invisible one here, they matter when naming molecular compounds. And so you have to indicate how many of each atom you have in the name. And so the way we do that is we use these prefixes here: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And these are the same prefixes that you would see in math. And I'm not sure actually what grade, but it is an expectation that you do memorize these prefixes. And in science in 9 and 10, and then especially in Chem 20 and 30, it is an expectation that you've memorized these prefixes. So please add these to your notes, make note of them, highlight them. And so what this means is if you ever have one atom of something, you would put mono in front of it. If you have 2, you would put di. And remember when we were talking about diatomic molecules, so examples being like hydrogen and nitrogen, that they're always found in pairs of 2, that di means 2. So diatomic, 2 atoms. If you have 3 atoms, you would say tri, 4 tetra, 5 penta. And so these prefixes are very important when naming molecular compounds, and you will have to memorize them, especially for grade 10. So right now I'm working with fluorine oxide. Okay. Now there are a couple of finicky rules. If your first element, if you only have one of your first element, so I only have 1 fluorine, I'm actually not going to put mono in front of it because it would seem redundant, unnecessary. So I just leave it as is. If you have 1 of the first element, you leave it. But the second element, oxygen, oxide, I have 5 of them. Okay? So I'm going to have to use the appropriate prefix for 5, which is penta. So then the name changes to fluorine penta oxide. Okay. If I do the next one, okay, CF2. Okay. So this means that I have 1 carbon atom, it's a nonmetal, and 2 fluorine atoms. Okay. So I'm going to put carbon, and I don't need to put mono in front of it. And then I'm going to find the prefix for 2. So that's di. So I'll put difluoride. I still change the ending to IDE, and I just add that prefix. Carbon difluoride. Okay. We'll do one more, a common one that we always see. CO2. Okay. So C is carbon again. And then 2, dioxide. Carbon dioxide. Okay. It's a really common one that we hear in our day-to-day lives. So this is a molecular compound. Carbon's a non-metal. Whoops. Carbon's a non-metal, and so is oxygen. Okay. Another one that we see a lot in our day-to-day is just CO. Okay. Now you don't hear CO very often, but it's carbon. Okay. And then the prefix for 1, because I have an invisible 1 after this O, is mono. And so then I go monoxide. Okay. Carbon monoxide. You might have a carbon monoxide monitor in your house. And so it is a product of incomplete combustion, which we'll talk about a little later. And so it's very toxic. If we are inhaling carbon monoxide, eventually you'll pass out and you could die. And so it's very dangerous for us. So a lot of houses will have carbon monoxide monitors. And so that's just CO. One rule that I need to touch on is you notice that I didn't go monoxide. I cut one of the O's out. Okay, so I didn't write it like this, monoxide. Okay, I wrote monoxide. Okay, and that's just a finicky rule that we have. I'll cut out that additional O. Okay. So, continuing on, there are a lot of molecular compounds, and a majority of them actually already have special names. And so how do you know if a molecular compound has a special name or if you're supposed to use the prefixes? So if a molecular compound, if 2 nonmetals are bound together and there is hydrogen present, then it'll have a special name, and you'll have to go to your data booklet or a list that your teacher will give you, and it'll have a special name. So these are some really common examples. Okay, H2O, you hear that all the time. It's a molecular compound. It means you have 2 hydrogen and 1 oxygen, but you notice that it has this hydrogen here. And we don't call this dihydrogen monoxide. You're never like, hey, pass the dihydrogen monoxide. It's water. And so chemists have come together and given these unique molecular compounds that contain hydrogen special names. And so the scientific name for H2O is water. Okay, and we call it water in chemistry. That's its name. Another really common one that you'll see a lot of in grade 10 is glucose. Okay, so it's a sugar. It's C12. Oh, no, I lied to you. It is C6. I should know this. H12O6. C6, H12O6. So this is a pretty big molecule. It's big. And so we need this in order to function in our day-to-day. You need sugar. You have 6 carbon atoms attached to 12 hydrogen atoms attached to another 6 oxygen atoms. And you notice that there's the hydrogen thing. So because it has a hydrogen, oxygen is a nonmetal. Oops. Carbon's a nonmetal, hydrogen's a nonmetal, oxygen's, they're all nonmetal. So it's a molecular compound. But because of this hydrogen, it has a special name. And that special name is glucose. Okay? And glucose rearranges into a lot of different forms like sucrose, fructose, galactose, glycogen, cellulose. Those are all types of sugars. And they're all just different amounts of carbon bound to different amounts of hydrogen, bound to different amounts of oxygen. But in simplicity, they're the same kind of compound. Okay? So writing chemical equations, we'll get into next week. One note is in writing the formulas for molecular compounds, okay, if I gave you one, let's just do the reverse. If I gave you fluorine, chlorine monoxide, okay? And I wanted you to write the formula for this, okay? You notice that there's nothing in front of fluorine, so you're just gonna write the symbol, F. And you're gonna look at the prefix here, mono. So that means one. In oxide, you'll find it's oxygen. So it's just FO. Okay. One more. Let's do dinitrogen, pentachloride. Okay, so the prefix there, di, is 2. Then you're going to find the symbol for nitrogen. So the symbol for nitrogen is N. You're going to tell me that you have 2 of them. So write the little subscript 2. And then chloride is Cl, chlorine. And you're going to find the prefix for penta is 5. So you're going to write 5. Okay? And so that's molecular compounds. Okay? Have a good week, guys. Bye.